All right, hello everybody. Welcome back. It might kind of feel like you haven't had a lesson in a while because our last lesson was on Friday, and then we had the weekend. Monday we did a quiz review, and Tuesday you took the quiz. So you probably miss having an ed puzzle, but don't worry. We have an ed puzzle today, and here it is. So today we're going to be looking at lesson 1.4. And in sections 1.1 through 1.3, you might have been thinking, all right, when we went through 1.1, it's a bunch of terms, which you kind of expect in geometry, things like a point, like a line segment, like a ray, and all that good stuff. And that kind of sounds like geometry. That seems like geometry. But then we got into all this stuff with like the midpoint formula. I shouldn't have started writing the whole thing out. With like the midpoint formula, with the distance formula, and then you're like, hold up, this seems more like algebra than it does to something like geometry. Well, don't worry. We're going to bring all of it kind of together here in lesson 1.4. So in 1.4, like it says, we're looking at perimeter and area in the coordinate plane. So remember, the coordinate plane is our XY axis, our plane, and we're going to have some shapes in the coordinate plane, and we are going to look at how can we find the perimeter or the distance around that shape, and how are we going to be able to find the area of that shape when it's in the coordinate plane. So that really is an overview of what we're going to look at today. And we will use, one more thing, we will use not so much the midpoint formula, but we'll use the distance formula for sure to do that. So our learning targets. Students will be able to classify polygons by their number of sides. So before we do that stuff with the coordinate plane here that I was talking about, that's a terrible arrow. There we go. There is some vocab that we need to go through, and it's going to have to do with classifying polygons. Students will be able to find perimeter of figures on the coordinate plane, sometimes having to use the distance formula. I think that's what I just talked about. Students will be able to find area on the coordinate plane, also what I just mentioned. So a little bit of, you could call it vocab, maybe a little bit of review before we get started. If we have, well, first, a polygon. Remember that a polygon, according to our book, a polygon is a closed plane figure formed by 3 or more line segments, which are called sides. So this is called a side, this is called the side, side, and side. I think we know that one. Each side intersects exactly 2 sides, one at each vertex. So remember, where these two, where BC and DC intersect, that is vertex, that point, vertex, 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 so that no 2 sides with a common vertex are collinear. You can name a polygon by listing the vertices in consecutive order. So we can name the polygon by listing the vertices A, B, C, D, E in consecutive order. No big deal there. One thing to note, a polygon has to be closed. So something like this right here is not a polygon because this side is not closed. So that's one thing to pay attention to. Types of polygons. I'm not going to expect you to have all of these memorized or have these written down, but a triangle, we know, because the root word, would it be considered the root word or a prefix? Because the beginning of it starts with tri, 3. Quadrilateral is a 4-sided figure. Penta, 5. Hexa, 6. Hepta, 7. Octagon, 8. This is where it gets a little bit tricky. Nonagon, 9. Decagon, a deca is 10. 9. Now this is where I can't even say them anymore. Dodecagon. We're going to have to look at, Mrs. Lenz is the expert on these things. So we might have to look at Mrs. Lenz for how to pronounce that one. And then N-gon, we won't really mess with this. too much, but that's just saying if there's like 20 sides to something, it'd be that kind of root word that there is for 20 with gone at the end, and we're talking about a shape then. Again, I don't expect you to have these memorized, but your book will refer to these things, and in problems I'll refer to these things as saying find, the area of the hexagon when it has these points. Well, if you can't remember that hexagon has 6 sides, it might be helpful to refer to this chart, and it is on page 30 in your textbook. Or you could take a screenshot of it now, and that would work as well. Now, kind of another defining term of these polygons. So we have 2 of them, convex and concave. A polygon is convex when no line that contains a side of the polygon contains a point in the interior of the polygon. So you can see this polygon over here. I mean, usually when we have a shape, we draw them as line segments, right? When we draw a triangle, it looks like this. We don't draw a triangle with a bunch of lines and then just think that the intersection is a triangle, right? This is not how we usually draw a triangle. We draw it like this. But really, when we draw these shapes, there is, especially in the coordinate plane, there's a line that is continuing to go past our shape. So in this case, we have a convex polygon because there's no line that contains a side of the polygon which contains a point. There's not like another point of this polygon in here. It doesn't dip down and have a weird point. On the other hand, we have concave, which just means not convex, so that we have really good definition there. Polygon that is not convex is concave. So like in this case, right, this is not the only line that keeps going. This line keeps going, keeps going, keeps going. But if we look, and I kind of muddied it up, but if we look, this line crosses another line on the interior of the polygon, so it's concave. You can kind of see those lines cross when they should not be crossing. If it just somehow stopped right here, we'd be good, but it cuts across the interior of that polygon. So let's look for a second. Convex or concave? Well, to find out, we can just kind of continue these lines as if they went on forever. Well, and you can see that this shape here in A, that if you were to continue this line, it'd cut across the interior of this polygon. And the same would happen for this line, so it has 2 lines that interfere. So that means that we have a concave polygon here. Now if we look over here, this is a 1, 2, 3, a hexagon, so that kind of gives it away. I don't really have to dot them in. That's terrible. But if these lines were to keep going, yes, they would cross. I mean, that's pretty obvious that you can see they would intersect here, which they should, but they never cross and break the interior of this shape. So that's a quick look at concave or convex. Now, something to keep in mind. This, let's see, area and perimeter, I think are 6th grade concepts usually that you learn in 6th grade, but in case you forgot, on page 31, at the top of page 31 in our textbook, it gives a quick reminder of the area, perimeter and area formulas that we'll need. So here we have perimeter of a triangle is adding up all the sides, the area of a triangle, 1/2 base times height. Same thing, perimeter of a square, you could add up every single side, or you could just find one side and multiply it by 4. So perimeter equals 4 times one of the sides, area is one of the sides squared. And then same thing, a rectangle is very similar to a square. Well, yeah. So all that to say, we have learned how to plot points. We know how to draw lines. We know about this whole coordinate plane thing. And we hopefully know from middle school how to find area and perimeter. Now we're going to kind of put those two things together. So a question that you might see in your homework is something like this: find the perimeter of the triangle. And they might have a picture for you, like I do here, of a triangle with the points, or they might just list the points. They might say you have point D, which is 1, 3, point F, -4, -3, point E, 4, -3. And they might just give you the points, and you might have to draw this picture. It is possible to find the perimeter and find the area without drawing the picture, but I think it's extremely difficult to do that. So, for this one, find the perimeter of the triangle. Now, there's one side that's going to be very easy to find the perimeter of. And hopefully you can see this flat side here is very easy to find the perimeter of, because we can just count the boxes for between F and E. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the perimeter, or the distance of FE is just 8. Whenever we have a side that's completely horizontal or completely vertical, we can just count the boxes, and that will give us the perimeter of that side. Now the problem comes when we have a side that is slanted. Like this side is slanted. We can't just count the boxes because it doesn't take up a full box, like right here. It doesn't go through a full box. We can't just count boxes on this side either. So that's where we have a little bit of an issue. Well, not an issue. That's where we have to do a little bit more work. So if we need to find the distance of FD, it's a good thing we learned the distance formula last week, because we can do that. So we need to use these points here and here, and we can find the distance using our distance formula of this diagonal side. So if I just say that this is my side 1, this is side 2, I know that the distance formula starts with x2. So I have 1 minus -4 squared plus y2, which I said was 3, minus -3 squared. So all I did is I said, all right, I can find this side here because it's horizontal, but I'll start over here to find this side so I can find the whole perimeter. I need to use the distance formula, so I'm setting it up. One minus a -4 gives me 5. 3 minus a -3 gives me 6. So this gives me the square root of 25 plus 36. Which is 61, the square root of 61, which is about 7.8. Okay, so we used our distance formula to find that this side has to be the square root of 61, and we'll just write that's approximately 7.8. Now, let's take a look at this other side. Right now we need to find from point D to point E. Again, I'm going to use my distance formula. And let's just say, well, I already have a 2 up here. So let's keep point D as my 2's and point E as my 1's for my x1 and x2. So I have x2, which is 1, minus x1 squared plus y2, which is 3, minus y1, which is negative, oops, negative 3. 1 minus a negative 3, which is really 1 plus 3, gives me 4 squared. 3 minus 3 just gives me minus negative 3. Why do I keep losing that negative sign? This gives me the square root of 52. This gives me 7.2. And if you guys round to the 10th place, that's great with me. That does not show up very well. So I know we kind of have a mess and I've erased some of my work. But again, I just counted the boxes from here to here on this bottom side for line segment FE because it's a horizontal line. So all I had to do is count. For FD, this was diagonal, so I had to use my distance formula, which we learned last week. And then for line DE, I also used my distance formula. Now, I need to find the perimeter. So to find the perimeter, I'll just add all of these up. So I have 7.8, 7.2, and 8. $14, $15, $23. So I ended up getting an even 23. They don't tell us what we're in, so you could say, ooh, units, and that would be good there. What you might also see, they might say find the perimeter, and then you could see something about finding the area. Now we know that the area of a triangle is 1/2 of the base times the height. So in this case, we said the base already we knew was 8. And now the height, now remember the height doesn't mean one of these slanted lines. The height is the imaginary line in the middle that comes at the base at a right angle. And the height, since it is a straight vertical line, we can just count it. 1, 2, 3, 4, 5, 6. One half of 8 is 4. 6 times 4 gives me 24. So the area of this triangle is 24 units squared, or units squared, or square units. Now, most of them, when we find the area, won't be quite this, I shouldn't say it won't be so easy, but they might not just be where we have to count. All you need to do is count boxes. There might be a little bit more to it, but the idea is that we'll use the formulas that we already know, to find area or to find perimeter. And really what we're adding on to it is that instead of just giving you a shape on a blank piece of paper and saying find the area, we're giving you a shape on the coordinate plane, like on here, or up here, a shape on a coordinate plane, and saying you need to do a little bit of work now to find the distance from here to here. We're just not going to give you and tell you that this equals 8. You're going to have to, well, that wouldn't make sense, 7.2. We're not just going to tell you that. You need to do a little bit of work using that distance formula to find what that is, and then apply what you know with those area formulas. So, if we look at our learning targets, classify polygons by the number of their sides. Well, that's what that big chart did for us with all the prefixes or root words, or whatever those were, triangle, quadrilateral, and all those on the table up here. So we classified. Also, a little bit of classifying, and it's not necessarily by the number of sides, but included in classifying was the convex and concave. That if a line breaks through, where we go? Since this line, as it keeps going, if it were to keep going, it breaks through the interior of our shape. That makes it concave, because it would cave in. That's how you could think of it. Here, with the hexagon, none of these lines break through the interior of our shape, so we can see, I guess I never wrote it, but it is convex. Find the perimeter of figures on the coordinate plane, sometimes having to use the distance formula. So that's exactly what we did. We had that triangle. We could find one of the sides, or we could find the base, I guess, just by counting the boxes, since it was a perfectly horizontal line, but we had to use the distance formula to find the other sides, and then find the area on the coordinate plane. So we're still finding those sides, well, finding the base, finding the height in that case, and we're using the area formula to find the area of that shape. On your homework, you're not just going to have triangles. You might have a square or some other shape that you need to find the area of, a square or a rectangle or something, but that same idea is going to apply. So if you have any questions, as always, make sure you send me an email.